All right, we were going over the two types of probabilities that we're going to be studying, theoretical and empirical. The theoretical is based on the mathematical probabilities of like rolling a six-sided die or picking a card or tossing a coin. Empirical probabilities are based on observations obtained from probability experiments, mathematical calculations of what actually happened, the number of times a particular event occurred at a certain number of trials, also considered to be a relative frequency of the event. Okay, so the observed frequency out of the total number of trials. So, for example, if you toss 10 quarters, when they land, you have gotten 6 heads and 4 tails. The empirical probability of heads is 6 out of 10, or reduced is 3/5, or as a decimal, 60%. With more tosses, you will eventually expect P heads to approach the theoretical probability of 50%. So basically, here, let me read the law of the large numbers. This is where this comes in, okay? As the sample size increases and increases, the relative probability of outcomes gets closer and closer to the theoretical probability value. The law of large numbers is the reason businesses such as health insurance, automobile insurance, and gambling casinos exist and make a profit. Okay, let's think about that for a minute. You're at the craps table and you're trying to roll a 7, or you don't want to roll a 7. You're thinking about the probabilities, probably not, but rolling once is just because it's a 50-50 chance of getting something you wanted, or a certain number of chance, doesn't mean that will happen. If you toss, maybe Baccarat is a better idea. If you're landing on banker 10 times in a row and it's a 50% chance it's between banker and player, you would think eventually it would start equaling out if it's a 50-50 chance. So 10 times in a row you hit banker, you might start wanting to hit player because you think it's going to swing back to the other side. But it's each time you roll, each time the event happens, it's still a 50-50 chance. There's not a greater probability that you will roll. If you roll 10 heads in a row, there is not a greater probability on the 11th roll, flip, coin, of whatever, that you will get the thing you haven't been getting. It's still 50-50 chance. It would be weird, but the more times you roll it, if you sit there all day and flip a coin, yes, you may end up with 50-50, the theoretical, okay? But meanwhile, you've gotten 12 heads in a row. It's weird, but it doesn't mean the 13th one's going to be a higher probability. You would need to sit there all day and flip that coin to try to get something as close to the theoretical probability of 50%. So that's what the insurances count on, because eventually it will even out over time. All right, so you can read through that. I need to get to the next page with more examples of actual. I just kind of did that discussion. You can read that on your own. Get this last page of empirical probabilities. Okay, observed. And this is a empirical observed in a frequency table distribution form set up here. Okay, you surveyed sample of 1,000 employees at a company and recorded the age of each. The probability of randomly choosing an employee who's not between 25 and 34 is the first thing we're looking for here in A. So let's look at this distribution table. Here's 1,000 employees grouped by age, okay? And this is the count. that was observed. There were 54 in this first group. Okay, so these are considered frequencies, how often there was somebody in that group. And when I added these all up, they better be 1,000 because I asked 1,000 people. So you want to make sure everybody got where they were supposed to go. Okay, so let's interpret this chart by finding out how many people were not in 25 to 34. So that is one of the groups right here. So a couple ways to do that. You could do 1,000 minus the 366, or you could add up all the other groups, because we checked, it all adds up to 1,000. Okay, either way, you should be getting 634 for everybody that's not in that age group. So 634 out of 1,000, 0.64. If fraction is required, this is reducible by 2, so depending on what they want. Okay. 25 to 64. Let's see. 25 to 64. They are 25 to 64. So a couple ways to do that. You can add up those 4 groups, or you can do 1,000 and subtract 54, the people that are not in those groups. And you should get 904 either way. So 904 over 1,000. Or if you divide by 8, you should get 113,125. Okay, or 90.4%. 63.4%, depending on what you want for your answer. Okay, so notice that there wasn't any expectation, there wasn't any theoretical probability of where they would fall. This is what we observed, so this is considered an empirical probability. Okay. Eye color of students in class, recorded. Doesn't tell me how many, so let's add all these up. 24, that's the sum frequency, sum of the frequencies. Okay. What is the probability of selecting a student at random from this course that he or she has blue eyes? Well, that's 5 out of, remember, this is the number of blue out of the total number. 5 out of 24. So make sure you take a moment and find that out if you're not given that. And that's going to be 3 repeating. Not having black or brown, so you can add up all the other ones or do the opposite. You can do blue is 5, green, hazel, 24. You can add up you can add up the other ones. We have brown and black is 15. 24 minus 15 is 9. So either way, we have 9 over 24, which is the same as 3 over 8, or 0.375, or 37.5%. Okay, relative frequencies are probabilities. It's important to know that probability statements mean what probability statements mean, and how to determine probabilities of events, because probabilities are the language of inferential statistics, which we'll be doing next. Okay. It can be said that the probability is the medium through which statistical work is done. The technique of using relative frequency as an event. Hold on. I really did that badly. Sorry. The technique of using the relative frequency of an event as a probability of that event is a common way of assigning probabilities that will be used a great deal in Chapter 11. That's what we're doing next. An interesting list of probabilities are in Chapter 10 on that page, calculated by statisticians who work for insurance companies, which are actuaries. All the different stuff that can happen to you. What is the probabilities on that page in your Alex textbook? Okay.